everyone, and welcome to the lesson on section 4.4, where we are going to talk about congruence and transformations. So the first thing we want to do here is define what congruent figures are. And congruent figures have the same size and shape. So everything about them is exactly the same, except for they may be rotated or reflected. But if you take a look at these shapes over here, these are all the exact same figure. They are just rotated and reflected. However, if you look at these triangles over here, this is a smaller version of this, so they are not congruent. And then this triangle here is completely different from these other two, so it's not congruent to either of those as well. When you have congruent figures, you can use transformations to map one figure onto another. And if you recall, a transformation is a rotation, a reflection, or a translation. Congruent transformation is also known as rigid motion or isometric motion. So let's do an example down here. And we want to describe a congruent transformation that maps quadrilateral ABCD onto quadrilateral PQRS. So what makes this blue quadrilateral map onto the green quadrilateral? Well, if you take a look at this horizontal side, it does not exist on the green figure. It has turned into a vertical side. That leads me to believe is that we have a rotation. What I want to do to start here is I want to take a look at point C. And point C has the coordinates left 3, down 5. So -3, -5. And I want to compare that to point R. R has the coordinate of +5, -3. And if we consider this to be our original XY coordinate, and then look at what happens to the XY coordinates in our new coordinate, our prime essentially, our -3 has been moved over to the Y position. So it's gone from the X position over to the Y position. So that means we have our X value in the Y position. And if we take a look at the Y value in this coordinate, it's the opposite sign in our R coordinate. So that would be a -Y. If you recall from our last lesson on rotation, this is a 90-degree rotation. 90-degree rotation follows the rule of taking your original coordinate and your prime coordinate will yield a -Y value and keep the X value but in the Y position. You could also take a piece of patty paper and trace our original figure, try some rotations. We're not sure where it's rotating about, but if we perhaps try rotating from the center, just as a good starting point, and rotate it clockwise, we can see that we can map quadrilateral ABCD onto quadrilateral PQRS. So this is a 90-degree rotation in the counterclockwise direction, CCW for counterclockwise. The next bit of information that we are going to talk about is using theorems for congruent transformations. And we are going to look at composite reflections. So we are going to work with two reflections that result in a figure that we can describe as a single translation or rotation for these two. First thing we're going to look at is reflections in parallel lines. And what we have here is we're going to have two sets of parallel lines. And what this theorem says is if lines K and M are parallel, then a reflection over line K followed by a reflection over line M is the same as a translation where the object will move twice the distance between lines K and M. So what exactly is that saying? That says that if we have this line here, AB, and we first reflect it over line K. We end up with this red line A prime B prime. And then we're going to reflect it again over line M. So we end up with line A double prime B double prime. You'll notice that these two lines are parallel to each other. So we have just a translation going over to the right. We can figure out this total translation without having to do any counting or crazy math if we know the distance between lines K and M. If we know this distance here, then the distance between A and A double prime is twice that distance. Over here, step 2 says take a look at A double prime, and it is 2 times the distance between lines K and M. Let's do an example with a figure, something a little bit more complicated than just a line. And we have triangle DOG. They want us to first reflect it over x equals 3 and label that D prime, O prime, G prime. X equals 3. 3 is located here. I'm going to draw my solid line in so I have that visual of where I'm reflecting. And we need to move everything the same distance away from this vertical line and perpendicular. Point D is to the left 1 unit, so the reflected point is going to be to the right 1 unit, straight across from it because we want perpendicular. O is also 1 unit away on the left. We want to move it 1 unit away on the right, so O prime is here. G, however, starts off on the right of this x equals 3 line, and it is 1, 2, 3, 4, 5 units away. We want to then go 5 units to the left, 1, 2, 3, 4, 5 of our line of reflection. This is G prime. If I connect my points here to get a visual of our reflected triangle, get this green triangle here. The next step says to reflect D prime, O prime, G prime over x equals -1. Let's draw in x equals -1 dashed line on this, just so I don't get my lines of reflection confused for this demonstration, and it's easier for me to visualize where everything is reflecting about. I'm going to start with G prime. G prime is 1 unit to the left of our line of reflection, so the reflected point will be 1 unit to the right of that line of reflection, and this will be G double prime. O prime is located on the right, and it is 1, 2, 3, 4, 5 units to the right. We need to go 1, 2, 3, 4, 5 units to the left, and there is O double prime. Now we need to calculate D prime, 1, 2, 3, 4, 5. On the right, let's go 1, 2, 3, 4, 5 to the left. Mark it D double prime. Connect our points. And this is our final figure, this purple one here. You can see that it is in the same orientation as our original figure. It's just over to the left, so it is translated to the left. We can figure out how far this translation is. We can see that there's a distance of 4 units between our first line of reflection and our second line of reflection, which means that if we take a look at from G prime here at 0, G double prime back to O prime, there should be a distance of 8. If we count 1, 2, 3, 4, 5, 6, 7, 8, there are 8 units. So just double that distance between the lines, and you can figure out how far your figure has translated to the left or right. The next thing we're going to talk about is reflection in intersecting lines. So now instead of parallel lines, we have 2 lines that intersect at some point, and they're going to have some angle measure between them. We will call that angle X. What this reflection of intersecting lines says is, if lines K and M intersect at point P, then a reflection over line K, followed by a reflection over line M, is the same as a rotation about point P. And then we can actually figure out the angle of that rotation. The angle of rotation is 2 times the original angle. Let's do an example so I can explain this to you. I have given you a figure, a triangle here, and the first thing I want to do is reflect this figure over line M and then over line K. This is not on a coordinate system, so what I'm going to do is actually trace this on patty paper to give me a fairly good, fairly accurate representation where this image will reflect. I'm going to make my lines nice and dark because I'm going to use those to reflect the image. I'm going to draw in line M, and I need to reflect this figure at over line M. I'm keeping my intersection point the same. And now I flipped my paper, so if I trace over my triangle that I originally drew on the other side of the paper, I can see it here on my paper. It took the pencil from the bottom side and put it onto the paper. Now I need to take this figure and reflect it over line K. So I'm going to draw a new figure on my patty paper, trace over my reflected image, get a nice dark line, and draw in my line of reflection. You can either just go from, you can draw on the intersection point like I did for the first reflection over M, or just draw on your endpoints and line that back up. Sometimes that's easier to do than drawing in the intersection point. And then, so we flipped our paper over again. Now our pencil's on the bottom of the paper. Trace over that top part. And this is our reflected image. It has a double reflection. So that's part A. Part B, describe a single transformation that maps the pre-image onto the second reflection. If we did everything correctly, and we draw in image, and we rotate about the intersection point, we should rotate back onto our reflected image, which we did. So we are actually rotating 2 times this amount. So going from here to here is 2 times 67 degrees. So I can easily calculate the total reflection. So 2 times 67 degrees is what our x is going to equal. And 2 times 67 is 134 degrees. So that is our total angle of rotation. Going backwards on an example, so now I'm giving you the final angle of rotation. I want to know what that angle is for the intersecting lines. So what would this angle be? So the example says a rotation of 158 degrees maps C to C prime. To map C to C prime using 2 reflections, what is the measure of the angle formed by the intersecting lines? So I know if I have this set of intersecting lines, I've got some angle x. If I put some point C here, and I go 158 degrees, say that's approximate. I'm not measuring this. This is nowhere near accurate. This is C prime, 158 degrees. What does this angle measure? Well, we know, based on the formula, that 2 times the angle gives us our final rotation degree. So if our final rotation degree is 158, we have 2 times x equals 158. So do your algebra and divide by 2, and we can figure out that x is 79 degrees. So these 2 intersecting lines are 79 degrees apart. This will be 79 degrees here. So in this lesson, we just talked about congruent figures and how to describe the transformation, as well as reflecting images over a set of parallel lines and intersecting lines. That completes today's lesson. Thank you for listening.